What if time, as we understand it, doesn't actually move forward in a linear fashion? What if our perception of its relentless march is simply a trick of the mind? What if it doesn't move at all? What if all moments, past, present, and future, exist simultaneously, a vast, unchanging landscape? We experience life as a river, flowing relentlessly from past to future, carried along by the current of time. Each moment seems to vanish behind us, replaced by the next. Yet some of the most profound and mind-bending theories in modern physics, the very foundations upon which we build our understanding of the universe, suggest this feeling, this deeply ingrained sense of temporal flow, might be a grand illusion, a construct of our consciousness. The universe, according to this view, a boundless expanse of space and energy, might not have a master clock ticking away at its core, regulating the rhythm of existence. There might not be a universal metronome keeping everything in sync. What we perceive as the relentless passage of time, the feeling of moving from one moment to the next, could be a feature of our perception, a quirk of our consciousness, not a fundamental aspect of reality itself. It could be how our brains process information, creating the sensation of movement through time. In daily life, events seem to happen in a strict, unalterable sequence. Breakfast, lunch, memories of the past, those cherished or painful moments that define us, anticipation of the future, our hopes and fears projected onto the unknown. This is what physicists call the arrow of time, the one-way directionality we observe, the seemingly irreversible progression from cause to effect. But when we look at the fundamental laws of physics, the equations that govern the behavior of matter and energy, they don't seem to care about the direction of time. They are indifferent to whether time is moving forward or backward. Most equations work perfectly well whether you run them forward or backward. The math remains consistent, regardless of temporal direction. This stark contrast between our lived experience, our intuitive understanding of time's passage, and the equations describing the cosmos, the very fabric of reality, is one of science's biggest puzzles, a profound mystery that continues to challenge our understanding of the universe. Why does our reality have a one-way street for time, a seemingly irreversible direction, if the underlying physics suggests a two-way highway, a symmetrical universe where time could theoretically flow in either direction? Is time a fundamental component of the universe, an intrinsic property of existence, or does it emerge from something deeper, a more fundamental level of reality that we have yet to fully grasp? Exploring this question challenges our most basic assumptions about existence, forcing us to reconsider everything we think we know about the nature of reality and our place within it. The arrow of time, a concept popularized by Arthur Eddington, highlights the difference between the reversible world of physics and the irreversible world we experience. Think of a cup shattering, never spontaneously reassembling. This is the thermodynamic arrow of time, linked to the second law of thermodynamics. Entropy always increases. The universe moves from low entropy at the Big Bang to higher entropy now. This increase in disorder explains why we perceive time as moving forward. Our memories too are shaped by this process. We remember the past, not the future, because the past is the direction of lower entropy. But for this to work, the universe had to start in a highly ordered low entropy state, a mystery in itself. If the universe began in equilibrium, nothing would ever happen. The arrow of time may be a local phenomenon tied to our universe's unique beginning. Even watching an ice cube melt is a glimpse into one of cosmology's deepest mysteries. At the heart of time's mystery is symmetry. In physics, symmetry means the laws don't change if you alter certain conditions. Most fundamental laws exhibit time reversal symmetry. They work the same forward or backward. Watch two billiard balls collide. The video looks plausible in reverse. This principle is central to classical mechanics, electromagnetism, and relativity. Yet our world is filled with irreversible processes: aging, decay, memory. The arrow of time emerges not from fundamental laws, but from the collective behavior of countless particles. A shattered cup is irreversible because there are vastly more ways for it to be broken than whole. Time's arrow, then, is a statistical effect, not a fundamental law. Some physicists find this unsatisfying, wondering if a deeper principle is at play. The search for answers pushes science to the frontiers of quantum gravity. Here, the rules of the very small and very large must be reconciled. To address the perplexing concept of time symmetry, where the laws of physics remain the same, whether time moves forward or backward, some physicists embrace the block universe theory. This theory offers a radical perspective on how we perceive time and its relationship to the universe. It's a concept deeply rooted in Einstein's groundbreaking theory of relativity, which revolutionized our understanding of space and time. Einstein's work laid the foundation for this mind-bending idea. According to relativity, space and time are not separate entities, but are interwoven, forming a single, unified four-dimensional continuum known as space-time. This fabric of space-time is the stage upon which all events in the universe unfold. The block universe theory takes this a step further, suggesting that all events from the cataclysmic Big Bang that birthed our universe to the ultimate end of time, however far into the future that may be, exist simultaneously within this vast four-dimensional block. Every moment that ever was, is, or will be, is already there. To help visualize this, imagine a loaf of bread, each slice representing a distinct moment in time, a snapshot of the universe at a particular instant. The whole loaf, from crust to crust, exists in its entirety at once. In the block universe, the past, present, and future are not sequential but are all equally real. Simply different locations, different coordinates within the grand expanse of spacetime. Therefore, our subjective sense of moving, flowing, or progressing through time is merely an illusion, a trick of consciousness, a byproduct of how our brains process information. If the block universe model accurately reflects reality, then every single moment, past, present, and future, is already fixed, determined, and unchangeable, like a scene frozen in amber. This deterministic view presents a profound challenge to our intuitive understanding of free will, suggesting that all our choices, actions, and decisions are predetermined, merely components of a pre-existing, immutable pattern. While this concept can be unsettling and counterintuitive, the block universe is a serious and logical consequence of Einstein's theory of relativity, which demonstrates that there is no single universal now that applies to everyone in the cosmos. What I perceive as now might very well be your past or your future and vice versa, depending entirely on our relative motion and position within spacetime. Therefore, the only way to reconcile these differing perspectives and maintain a consistent picture of the universe is to treat all moments in time as equally real and existing. The universe in this view simply is a complete and unchanging block of spacetime containing all of history, all at once. The idea that time is not fundamental but emergent is gaining traction in physics. Emergence means complex patterns arise from simple rules like snowflakes from water molecules. Similarly, temperature is emergent. A single atom has no temperature. Some physicists propose time itself emerges from a timeless reality at the quantum level. Our perception of flowing time arises only at the macroscopic scale. This helps resolve the conflict between time-symmetric laws and our time-asymmetric world. The arrow of time may be a statistical illusion, not a fundamental property. To understand the universe's deepest level, we may need to abandon our intuitive notions of time. Evidence for a timeless universe comes from the Wheeler-DeWitt equation, which describes the quantum state of the cosmos. Strikingly, this equation lacks a variable for time. In this quantum view, the universe is static and unchanging, a superposition of all possible states. How do we reconcile this with our experience of change and motion? Time, according to this idea, emerges from relationships between things, not as an external clock. Imagine a universe of three particles. Change is measured by their relative positions, not by an absolute time. Time is an internal property, defined by the configuration of the universe. The ultimate theory of everything might be timeless, describing possible states and their probabilities. Our experience of flow is a story our consciousness constructs from these static states. Carlo Rovelli, a prominent figure and a leading voice in the field of loop quantum gravity, a mind that challenges our fundamental understanding of the universe. Rovelli provocatively argues that time, as we intuitively perceive it, is not a fundamental feature of the world, not an inherent property of the cosmos. Instead, he posits that time arises from our incomplete description of reality, a consequence of our limited perspective and the coarse-grained way we observe the universe. Zooming into the quantum level, the universe reveals itself as a dynamic network of interacting events, a ceaseless dance of particles and forces. At this fundamental scale, there's no smooth, continuous time flowing uniformly, no grand cosmic clock ticking away. Time, as we experience it, emerges only when we step back and view this intricate network from a macroscopic perspective, when we blur the quantum details. Rovelli draws an analogy, comparing time to heat, a concept that helps illustrate his point. At the microscopic level, There's only the ceaseless, random motion of individual atoms. There is no heat per se. Heat is simply our large-scale statistical description of this collective atomic motion, a way to summarize the energy distribution. Similarly, in loop quantum gravity, space-time itself is not continuous, but is made of discrete quanta, fundamental building blocks of space and time. These quanta interconnect, forming a dynamic and ever-evolving network called a spin network, the very fabric of space-time. Within this framework, there's no external clock dictating the rhythm of the universe. Instead, change is relational, defined by the interactions within the network. Each part of the universe evolves and transforms relative to all the other parts, a cosmic dance of interconnectedness. Time, therefore, is not an absolute entity but rather the measure of these relative changes, a way to quantify the evolving relationships. It's an internal clockwork, intrinsic to the universe itself, not imposed from the outside. Rovelli's radical view offers a potential way out of the Wheeler-DeWitt paradox, a long-standing problem in quantum gravity. The universe in this light isn't a static, frozen entity described by a timeless equation. Instead, it's a seething, dynamic network of quantum events, constantly fluctuating and interacting. The concept of a universal flowing time, a single timeline for the entire cosmos is, according to Rovelli, an illusion, a convenient fiction. Instead, there are countless relative times, each valid within its own context. Each of these relative times is defined by the specific interactions between different parts of the universe, a local perspective on the grand cosmic dance. Our own perception of time, the way we experience the passage of moments, is just one of these countless relative times. It's intimately tied to the complex biochemical processes unfolding within our brains, the neural activity that shapes our consciousness, and our bodies, the biological rhythms that govern our lives. In essence, we are clocks, intricate mechanisms of biological timekeeping. We are constantly measuring our own internal changes against the backdrop of the ever-changing world around us. Therefore, we are not passive passengers on a pre-existing river of time, simply being carried along. Instead, we are an integral part of the river itself, contributing to its flow and shaping its course. The quest to understand time spans from thermodynamics to quantum gravity. The thermodynamic arrow of time explains why events move from order to disorder. But at the quantum level, physicists ask if time exists at all. Theories like loop quantum gravity and string theory suggest space and time might emerge from a deeper reality. Connecting the timeless quantum world to the arrow of time is a major challenge. Some, like Julian Barber, propose that the illusion of time's passage comes from the universe's growing complexity. Studying the cosmic microwave background helps scientists probe the universe's low-entropy beginnings. The search for time's origin is a search for the universe's origin itself. If time is an illusion, what does it mean for us? Practically not much changes. We still live by clocks and calendars. The emergent reality of time is the one we inhabit, with all its rules and rhythms. But philosophically, this perspective is transformative. The block universe suggests every moment is eternal, part of a cosmic tapestry. It challenges free will but also offers comfort. Every moment, every loved one is forever written into space-time. Science shows our deepest intuitions can be wrong. Time's flow may be a product of our limited perspective. This humbling realization encourages curiosity and open-mindedness. The journey to understand time is ongoing, pushing the boundaries of science and philosophy. Whether time is fundamental or emergent remains one of science's greatest mysteries. Follow ScienceDeeps for more mind-blowing science facts.